We'll be looking at the video solutions for the kinematics part in a NEET Test 3. Questions are majorly from projectile motion as well as circular motion. The very first question we will tackle is this assertion reason, this which is question number 116, if I'm not wrong. Here, the statement 1 is saying centripetal and centrifugal force are acting in the opposite direction and they balance each other, which is perfectly correct. Centripetal force is a force which acts always toward the center of any rotating object, according to whom? According to an observer standing on the ground. But if you yourself were to be the object, suppose you are the object which is spinning, right? You would not experience a centripetal force, rather, you would experience a constant outward pushing force called as a centrifugal force. So, what is the biggest difference between centripetal and centrifugal? Centripetal exists for an observer who is looking at the rotation standing on the ground and he is not rotating. Centrifugal exists for that observer who is rotating on the circle himself. The centrifugal force is always pointing outwards, centripetal force always pointing inwards. They have the same magnitude but opposite directions. So statement 1 is absolutely right. But statement 2 is false. Centripetal exists at the same time, centrifugal also exists. There can't be any instant of time where there is only centripetal or only centrifugal. They always coexist. They always act at the same time. Hence, statement 2 is false. Statement 1 is correct. So that is the right choice for question number 116. Now, question number 118. A particle is moving along a circular path with constant speed. Yes. What is the magnitude of the change in velocity of the particle after it moved through an angle of 60 degrees? Here is where an understanding of circular motion shall help you to, uh, calculate the answer pretty quickly. Uh, how is it? Uh, let's say, let us say initially the object is moving upwards at A and it turned through an angle of 60 degrees and now it is at B. Okay. So from A to B, it went 60 degrees. They're asking what is the change in velocity. Do not make the mistake of making or ticking zero. They are not asking change in speed. Change in speed is zero because speed is constant. They're asking change in velocity. So velocity is a vector quantity. I need to seek the difference of this vector and this vector. For that, I do very simple thing. This is 90 degrees, so I shall trace this backwards. If this is 90, this shall also be 90. Consider this triangle. Okay, this is 90, this 60, so this shall be 30. Remember, if this is 30, then this angle shall be with the vertical 60 degrees. Why did I do this? You will understand now. There are two vectors. The upright one is at A, this one is at B. The angle between these two vectors is 60 degrees. The magnitude of these two vectors is 10 and 10 each. How do I calculate the difference between the two vectors? The difference formula, of course, square root of A square plus B square minus 2AB cos theta. Theta is 60, so cos 60 is 1 by 2. Okay, which gives me 10 meter per second. Voila, I got the answer 10 meter per second. If not, I would have to resolve the vectors and get the answer in terms of I and j, take the magnitude. The easiest way to do this is visualize the two vectors tail to tail. The angle between them is anyway 60 degrees. Then use the difference formula, difference of the two vectors. That is 1, 1. Now, question number 119. Again, the sum formula, the sum of two vectors formula would help you here in question 119. The uh, there are two forces, 2F and 3F, that they are at an angle theta with each other. If the force Q is doubled, okay, force Q. Let's first find out what is force Q. Force Q is 3F. Now, if 3F becomes 6F, then the resultant also gets doubled. First of all, let us find the This is for question number 119. Let us find the resultant with 2f and 3f. It would be 2f square plus, so 2f and 6f. Okay, 2f square plus 6f square plus 2 into 2f into 6f, right? That would be 24f square cos theta, a square plus b square plus 2ab cos theta. With that, this is exactly 2 times resultant of 2f and 3f, which is 2f square plus 3f square plus 2 into 3f into 2f, which is 12f square cos theta. Okay, so this is the data given. Now we have to find the angle here. So with this, we can set out, you can substitute the values of theta or solve the equation and get the answer. The resultant, this resultant is twice the earlier resultant. And there lies the question. I think the answer is obvious if you try to simplify. Okay. So, well, now we get into question number 120. 120 is slightly conceptual, I would say above NEET level. Here you need to know a keyword. The keyword is just being. So the body is able to just complete the uh, circle. The body is able to just complete the circle. So let us let it revolve in a vertical circle. If the body is able to just complete the circle at its maximum or at its topmost point, its velocity is always going to be root of gr, something which we will derive in work per energy more extensively. So at the top, the object will always have the speed of root gr if it is able to just complete a circle. And let us assume that this is the ground and this whole distance is 2r. At the instant when it is at the top, the string breaks. So due to inertia, this object will be like a horizontal projectile and it will fall on the ground. Okay, what is the velocity of the stone at the instant when it breaks? Due to inertia, it will be root gr. So it will trace a projectile path like this. Now, how would I find the range? Range formula for horizontal projection is we very well know u root 2h by g, where u is the horizontal velocity, h is the height from the ground. Now h is the diameter, which is 2r by g. Okay, so from this we would arrive at the answer. Right? Root of gr into 2r by g, u root 2h by g would be the answer for this. That is for question number 120. Now, question number 121. A particle moves in a circular path with decreasing speed. Choose the correct statement. Here we know the correct statement, right? Should be, we need to evaluate each one. So angular momentum remains constant. No, it doesn't, because angular momentum is mvr. Radius and mass remains the same, whereas v, speed, is decreasing. Hence, angular momentum doesn't remain constant. Statement 1 is false. Acceleration a toward the center, they have given bold. Bold letters means vectors, right? Though there will be one component of acceleration towards the center, since the speed is decreasing, there shall be a tangential component of acceleration as well. The resultant of these does not point towards the center. It doesn't point towards the center. So P is also false. The particle moves in a spiral path with decreasing radius. Of course not, because they themselves have given it moves in a circular path. So C doesn't seem to be fitting. So right option should be D. 121 goes with D. Now, question 122. A man can swim at a speed of 3 kilometers per hour in a still river. He wants to cross a 500 meter wide river flowing at 2 kilometers per hour. He himself always keeps an angle of 120-degree with the river flow while swimming. Okay. The drift of the man when he arrives at the opposite bank is. So this is a basic river velocity problem, river man problem. So let this be 3 km per hour, and let this be 120 degrees. So this shall be 60 degrees, right? And the width of the river is 500 meters. With this, or like going like this, he will soon reach a point directly opposite. This is called the drift of the man. How much off he is from a point directly opposite to drift of the point. How do you find the drift? Drift can be found out first by finding out the time taken by the person to reach the bank. How is it? We first find out the vertical component of the man. The vertical component Vy is 3 sine 60. And what is the distance of the river? The distance of the river is the length of the river is 500. Okay. Now, how do you find the time taken? Time taken is the vertical distance by vertical velocity. So 500 by 3 sine 60. One catch, 3 is here in kilometer per hour. You multiply it by 5 by 18 to keep it consistent with meter per second. So you got to know the time taken by the person to reach the opposite end. How will you find the drift? Drift is in the same time he was seen moving horizontally with a velocity of 3 cos 60. So drift is horizontal component into time taken, which is 500 by 3 sine 60. Okay. So here this would be right, and 3 km per hour anyway would be getting cancelled, and you know how to simplify the rest of them. So drift is the horizontal component into the time taken by him to reach the opposite end. And what is the time taken? Time taken is the distance by the vertical component, because time is distance by speed. The vertical component is 3 sine 60. So this should be for the question number 122, and as well as the question number 123. Question number 122, sorry, 122 and 124. Right? Now, question number 123. A body is moving with a certain velocity in a circular path. Now the body reverses its direction. This means, let us say earlier it was going clockwise. Now suddenly it shall begin moving anti-clockwise. Will the magnitude of centripetal force remain same? Yes, because it is v square by r. Speed didn't change, only the direction or the circulation direction changed. So magnitude will still remain the same. Direction, of course, yes, direction is always toward the center, whether clockwise or anti-clockwise doesn't matter. The direction of centripetal acceleration remains the same. That also is correct, right? And what about the direction of centripetal force doesn't change? That is also true, because it is always pointing uh, towards the center. It appears more or less all choices are correct. So this would be question number 123. Now, question number 125. They have given length of the second's hand is 3 centimeter. What is angular velocity and what is linear velocity? The basics of circular motion, where the radius, let this be the tip of the second hand. The radius would be around 3 centimeter, and this is rotating. Okay, it should be clockwise since the second hand, right? So, what is the angular velocity? Angular velocity omega is 360 degrees, 2 pi, by the time taken for the second hand to complete one, revolution. That would be omega equal to 2 pi by t. Time taken by the second hand to complete one revolution. Find out that time, which you all know by looking at a clock. Omega equal to 2 pi by t. That would be the linear velocity. How do you get that would be the angular velocity. What would be the linear velocity? V is equal to r omega. After having found out omega, you put that omega over here, and in place of r, you put 3 centimeters. But look, all options are in SI, so it will be 3 into 10 power minus 2 meters. So you put these, find out the time taken by the second hand to complete one revolution, and that's it. That is, and the formula would do the rest of the job. So this is 125th question. Now 126. A body executing UCM, uniform circular motion, is the key. So the speed isn't changing. Therefore, acceleration will purely point towards the center of the circle. And what about velocity? Velocity is always tangential. What is the direction? What is the angle between the force and the velocity or acceleration velocity? It is always 90 degrees. In UCM, it is 90 degrees, or it is always normal to each other. This is question number 126. Now, question number 127. Interesting. Here you need to visualize the cyclist. Initially, cyclist starts from A, he goes to B, and he takes a 60-degree turn, it seems. So this angle is 60 degrees. He goes for some more distance C, he goes for some more distance D, and again, let us say E, right? And then again F, and then again back to. What figure is this? This is a regular hexagon. So the angle, right? A regular hexagon. So he is going around this regular hexagon. Cool. But um, we should ask ourselves, if it is this, he tracks 60-degree turn after every 100 meters. So this is 100, this is 100, this is 100. Let's say this is 100, this is 100, this is 100. You can imagine it like to be so, though it is not strictly a regular hexagon. You can imagine it to be so. What is the displacement when he is about to take the seventh turn? So this point is the first turn, second turn, third turn, fourth turn, fifth turn, sixth turn, and seventh turn ho gaya. So at after seventh turn, what is its displacement? After the seventh turn, initially the position was A, now it is B. The displacement is around 100 meters, right? So that is the logic for question number 127. Now, what is the angular velocity of Earth? Question number 128. Angular velocity of Earth, omega, is 2 pi by t. Everything is in seconds, so even the t has to be in seconds. What is the time taken by Earth to complete one rotation about its axis in seconds? That would be 24 hours into 60 minutes into 60 seconds, around 86,400. So that would be this 2 pi by 86,400. Well, the question is actually ambiguous. The reason being they're not asking whether we need to find angular velocity of Earth due to spinning motion, or is it due to rotation around Sun. That is not clear. So what we have found out is spinning angular velocity of Earth. What would you do if it was, the orbital motion? For that, you would use 2 pi by t, but t would be 365 days, and each day would be having 86,400 seconds. So this would be the uh, the orbital angular velocity of the Earth, whereas this is spinning angular velocity of the Earth. So that is question number 128. Now, question 129. A stone tied to one end of the rope rotated in the circular motion. If the string suddenly breaks due to inertia, we all know it will go in the tangential direction. 129 goes with D. Now, question number 130. In question 130, kinetic energy is given as E, find the acceleration. Now, you need to know basic of kinetic energy. Kinetic energy is half mv squared. And what is then they're asking what is acceleration? Okay. Well, how do I express acceleration over here? We know acceleration is v squared by r, centripetal acceleration. Why only centripetal exists? Because it is moving in UCM. So the only acceleration that exists is centripetal acceleration. What is v squared? V square from the above equation, V square can be written as 2E by M. V square can be written as 2E by M. You put 2E by M over here, so you get acceleration equal to 2E by mr. So the right answer would be A, 130A. All you needed was to know your 10th grade formula. Kinetic energy is half mv square, and then the 11th grade one, A equal to V square by R. Express V square in terms of E, and then put in the equation. Now, question number 131. The radius is doubled. What will happen to centripetal force to keep up the same speed? Centripetal force is given by mv squared by R. Mass is not being changed, but they are telling radius has been doubled. So R becomes 2R and speed is the same to keep up the same speed. So what happened to the force? Earlier, force was only mv squared by R. Now the force is mv squared by 2R. I can say that the force has been halved. So it has become half of its original value. So this is a basic understanding of centripetal force. Now, question number 132. In such questions, it is less of the kinematics and more of units. 10% is always a less change. So how can I find a percentage increase in the range? Just by R is equal to U square sine 2 theta by G. Sine 2 theta and G are constants and it is not changing. So how do I find range now? By using the concept of units, measurements, and errors, delta R by R is 2 times delta U by U. This delta U by U has been given as 10%. So 10 into 2 is 20%. So the change in R, the percentage change in R is 20%. Remember, the maximum percentage you can use for doing this in a units measurements way is around 10%. Do not use it for large percentages. It is only for small changes like 10% and stuff. You can use. That is question number 132. Now, question number 133. Horizontal range of a projectile is 4 root 3 times the maximum height. Then what is the angle of projection? We will use h by r is tan theta by 4, right? Now, range is 4 root 3 times h. H cancel, 4's cancel. So I have tan theta equal to 1 by root 3. Tan of what angle is 1 by root 3? Tan of 30 degrees is 1 by root 3. So the angle of projection is 30 degrees. Now, question number 134. What is the change in momentum experienced by the body along the y-axis between the starting point and the highest point? It is a club of a momentum concept and a vector concept. At the highest point, vertical velocity is 0. At the initial projection, we all know the vertical component is u sine alpha. How do you find the momentum change? Delta py, momentum change along y-axis, is m into vy minus m into uy, where m is mass, final vertical momentum minus initial vertical momentum. Vy is anyway 0. So what is uy? Uy is u sine alpha. So the answer's magnitude should be mu sine alpha. So mu sine alpha is the correct answer. Of course, if you want to do it very quickly, you can still go ahead and do alpha equal to 90 degrees. 90 degrees would mean that you are throwing the stone directly upright. Initial velocity is u. At the highest point, velocity is 0. Change in momentum would be m into 0 minus m into u or mu. Which of the options gives you mu only when you substitute alpha as 90? It is option B. Therefore, 134 goes with B. 135 by now has been a very famous question. Again, a horizontal projection one. The aeroplane is at a height of 1960 meters from the ground and it releases a bomb. The bomb is going with 216 kmph and it will hit the ground at some point over there. Now, what is the distance AB is what is being asked. Again, we go with the traditional formula. R is equal to U root 2h by G, and U is given as 216 kilometers per hour. Let's try to convert it to, you know, meter per second. 216 5 by 18 times. What is the height? The height is 1960. Okay, and let us keep G as 9.8 itself. If I keep G as 9.8, what's the advantage? 98 and 196 can get cancelled, so I kept G as 9.8. So this will give me range in meters. So if at all the option has kilometers, we'll convert it to kilometers by dividing by 1,000, and then we shall uh, go. So this is the these are the solutions for your NEET paper 3. Many of them are simple. One of the most complicated question conceptually was this horizontal distance covered by the body of the string brakes. I hope you got to know the funda. The funda would be R is equal to U root 2h by G, and then you find out U, then 2R by G. So, well, that is about the this section. I hope you got some benefit by looking at these approaches. Please make a note, revise regularly, and see you in the next installment. Keep doing physics, have fun with physics. Take care.